everybody, Rachel coming at you today from Keats, Kansas. The corn is looking really good here. We're looking at what the tillers are doing today. We're about R3 for the main plant in these plots. So right now I'm standing in our 10,000 per acre density. So this is our lowest density that we're looking at. We've got a 10, a 17, and a 24,000. And I picked this specific plot because we have a lot going on with tillers here. If you can see right by my head here, we have a big tassel ear here. There's other ones here and back there. They're everywhere in this plot. And I've got one in my hand here. I wanted to talk just a little bit about tassel ears and just kind of what's going on here. So corn is a really special crop because the male and the female flowers are in separate parts of the plant. So the tassel, all of the male flowers stay, but the female parts of the flowers are aborted. The plant will specifically abort either the male or the female depending on which part of the plant it's found on. And so in corn, the ears should be all female, the tassel should be all male, but what happens sometimes is that process doesn't quite work correctly, and that's when we get these weird mixes in the sex of the flowers in the different parts of the plant. So if you'll think to a normal tassel, you'd have a central axis and then branches coming off of that. The first part of that tassel that develops, the first part where the flowers are developed, is the middle part, that central axis. And most of the time, the tassel ears that we see in these tillers, it's the central axis that is female. And then we have branches that are male, which tells us that the first part of the tassel flower initiation process was where the imbalance was. But then that imbalance was overcome because we see that these branches developed normally as male. So the environment or the hormone or whatever it was that was causing that change started out as being off, and then as we reached the branches, it became normal again. And not every tiller has a full center part. I'll grab another one here so you can see this one. In this case, the process or the imbalance was remedied much sooner, because you can see that this would be where the first flowers were initiated, the center of this main axis. As it went out, as it started developing, it went out like this. And so you can see that the balance was normal faster for this tassel than for this one. And so what we're trying to figure out is what causes this, if there's anything we can tie to the number of tassel ears that develop, because obviously we don't want to see this. You can see probably in this one that I'm holding, we've had some Japanese beetle pressure and other insects that have been eating on this tassel ear. And so there's not going to be much left. Probably won't be anything left on these tassel ears by the time harvest rolls around. So this is a waste, basically, in our mind. Tillers can put on normal ears. I have an ear from a tiller that was right next to these, actually. So we can get normal ears out of these. This is a little bit behind. You'll notice that these silks are still white. Most of the silks on the ears out here are already brown, which means that pollination is pretty much over. These tillers were quite a bit later than the main plant here in Keats, and so that could definitely spell problems for pollination on these ears. Another thing with tassel ears is smut. So smut is caused by a fungus, and that develops in the corn plant. It can happen to ears, it can happen to leaves, to stalks, but it basically balloons out in this really nasty white and gray fungus, which I say nasty, it's actually a delicacy and people will eat it in some countries, in some parts of the world. I am not part of that crowd, but we do see some of that in tillers also. Although we are seeing that in main plants here as well. In our lower populations, we're seeing quite a bit of smut here in Keats also. Now, not every tiller puts on a tassel ear. There are cases when we see normal ears. Some locations we don't see any tassel ears at all, and it's all normal. But in Keats, it's looking like for the second year in a row out here, we've got mostly tassel ears. So something about this location, whether it's the weather patterns or maybe the soil, there's more nitrogen here or less nitrogen here or something. We'll have some work to do to try to figure out why that is, but that's the next step of this project. And yeah, I just wanted to show you guys what we were seeing out here. Tillers, tassel ears, we've got kind of a mess here in Keats, but it'll be interesting to see what yields do, how that affects yields, even if we're not getting grain from tillers, if we are penalized for that and how much that penalty is. But yeah, looking forward to some data here in Keats. Thanks for tagging along, and we'll see you next time.